everyone. Welcome to our November fundamentals of the Naperville Astronomical Association. I'm the current club president, Jim Irwin. Tonight, our speaker is Charles Mudd of Mudd Law. He's going to be talking to us about SATCONS and some of the legal issues going on with them. So I will turn it over to you, Charles.
Great. Thank you. And Jim, for that introduction. And what I'm going to do today, as was mentioned, is talk about SATCONS and what they are, what are some of the issues, and actually, let me get back to the beginning slide here. Hold on just a moment. So what we're going to do is talk about satellite constellations, their effects, what are some positive things, some negative things, and what is all this about. And as one of the slides indicates coming up, you know, it's really interesting, and Jim, you mentioned this by email as well, that 3 members of the Naperville Astronomical Association participated in the SATCON workshops, which I'll be talking about, particularly SATCON 2. So it's really, I think, for this organization, a significant reflection of not only the thought leadership that comes out of the organization, but the passion of the people involved. So what are SATCONS, and when did the issue of satellite constellations begin? Well, really, it probably began most significantly in May 2019. This is when SpaceX launched its second set, but its first set of 60 Starlink satellites. So there were 2 test satellites that it had previously launched, and then in May of 2019, it launched the first set of 60. And you can see on the screen here, the satellites streaking across the night sky. This was video courtesy of Marco Langbroek of in the Netherlands, sorry. And so when that image appeared, astronomers, people interested in the dark sky, really became concerned, because what did this mean? Well, the image that you see here is now a classic image that is taken from DCAM telescope. The DCAM stands for Dark Energy Camera. It's on the telescope in Chile. And this happens to be an image not at the same time as the other Starlink satellites that we just watched on the video. That was May of 2019. This image is from November of 2019. And you can clearly see the satellite streaking across the image. So this demonstrates the concern that the astronomers and the astronomical community started to have about what satellite constellations, but generally what satellites would have on astronomy, particularly observational optical astronomy. That is like here, where we're taking an image, visual image of the night sky. How much are these satellite streaks going to affect the imagery? And, you know, when you consider the fact, taking a moment here, when you consider the fact that a lot of the observatories are not so much rented out, but there are blocks of times that you have to allocate and you have to secure. And that may take months to secure that space, that time that you're able to use that telescope, the observatory. And so if you got a small amount of time, very narrow window, every second counts, literally every second counts. And so to the extent that the satellites start to mess up the imagery, even whether it's 1 streak or here about 26, I believe, or thereabouts, it can impact your research. So With that in mind, excuse me, I'm coming off of a cold here. With that in mind, in June and July of 2020, last year, the AAS, the American Astronomical Society, and the National Science Foundation, NSF, and NORLab gathered together, and they had the first SATCON meeting, SATCON 1. I'm going to move this out of the way since I can. So SATCON 1 brought together a number of interested parties, including astronomers, of course, satellite operators, dark sky advocates, policymakers, and other stakeholders and interested parties. They came together and created an executive summary, or an executive summary was created. And then they also came out with the report, the SATCON 1 report. And in the SATCON 1 report, there were a number of recommendations, and they were broken up into three kind of working groups. The first were observatories focused on, or the working group the recommendations were focused on observatories, the first set, to develop software for satellite trails. And that would mean software that, going back here, that would be able to identify correctly satellite trails, remove them from the image without affecting the surrounding area, and without misidentifying what would otherwise be asteroid trails or something of that nature. So that's what we're talking about when we're talking about developing the software for satellite trails. Develop software for observation planning. So this software would then, as an example, would allow one to, if you did have observation time and you knew when the satellites were going to be launched, or not only just launched, but orbiting through the field of view, or where you were going to be using the telescope, what your research wanted to be, then you could plan the telescope accordingly. And you could, ideally, you'd even be able to plan it down to the second. As I said before, seconds count. So if you knew that the satellites were going to cross through the field of view at a particular point in time, you could shut more or less the shutter for that period of time and then reopen it, because a lot of these images have long exposures. So for example, the DCAM image that I showed you before was an exposure of 333 seconds. So if it had taken, if we had removed 10 seconds of that, added it onto the other end, beginning or end, we'd still have substantially the same image without the streaks. Further, support detailed simulations of effects. So to simulate what the adverse effects of satellite constellations would be on observational astronomy. Now, I'm talking about optical here for the moment. We're talking about, the visual component of seeing the streaks through the night sky. But I do not want to overlook the fact that there are also concerns that the satellites could have on radio astronomy as well as infrared astronomy. There were also recommendations for the constellation operators, such as SpaceX, to perform measurements in the design process. And this is really compliance by design, or trying to get the operator to think about these issues in the design process ahead of time, so that it's less costly for the operator to change something, to mitigate by changing the technology. Certainly, once it's launched, it's difficult to change anything, but you don't want to start implementing changes at the end of into the manufacturing process of the satellites. The more that you can incorporate these concepts in the design, the more it's going to be better for everybody. Ideally, the satellite operators have their satellites reflect sunlight on a brightness less than 7 magnitude. Third, use their best efforts to avoid specular reflection, and provide post-launch configuration and information. The information is critical on the telemetry and the orbital data for the satellites, particularly tying back up to observation planning, you have to have accurate information to be able to do that. And if you go to the website Celestetrack, I think it's .org, celestetrack.org, you can look at information that can be used to track satellites, and I can show you an example of that perhaps later. But that data is not to the minute, to the second, up to date. And what we really need to be able to do observation planning is information that's going to be much more accurate. There were also recommendations for both observatories and constellation operators. This, again, is to have optical observations for measurements, determine cadence and quality telemetry, and develop a new standard beyond the two-line element. The two-line element, if you go to Celestetrack and you look at the TLEs, you'll be able to see what I mean by two-line element. And actually, a lot of it's like a three-line element, because the first line is the name of the satellite, but the other two have a lot of information about the satellite. But let's take a step back for a moment. SATCONS, what really are we talking about? There's a difference between a satellite constellation and a mega constellation. Mega satellite constellation, that is. So when we think of satellite constellations, we can look at a number of different sources. So here's an image from the FCC. You can pull this up quite easily from the FCC's website about these are satellites that have been authorized and are listed by name. So you have the company name, the call sign, the satellite name, the orbit location requested, assigned, the file number, the date that it might expire, the license that is, the date that it was filed, whether it's GSO or NGSO. GSO meaning geostationary orbit, N meaning non-geostationary orbit, and the frequency band. You can also pull down from the concerned scientists a satellite database. This one here is current as of September 1st. The print is probably way too small for you to read, so I'm not expecting you to do that. But they also have information about the satellite, the country of the UN registry, the country of the operator owner, and the actual operator owner. Here, for example, many of these are Starlink, and you can see that SpaceX is the operator. Well, maybe you can, maybe you can't. This one here, right here, is Starlink DarkSat. So let's take a further pause. And earlier I said that ideally you would not have to have the satellite operator or manufacturer get to the end point of the process and then incorporate a design change. Well, that's what happened with SpaceX, but it didn't have to. I have to give SpaceX credit for working with the astronomical community in trying to develop means to mitigate the solar reflectivity of their satellites. Not only did they participate in SATCON and Dark and Quiet Skies, which I'll get to, but they also focused on developing technology to mitigate the brightness of their satellites. So they obviously could not do anything with the satellites already up in space. One might argue that maybe they could shoot them down, which Russia just did with testing an anti-satellite technology, which created a field of debris and a number of concerns. You may have read that individuals on the International Space Station had to get their spacesuits on, take precautionary measures because of the risk of the debris. We do not want to do that. ATSAT capability, anti-satellite capability is not a good thing, not something that should be advocated. And in my mind, I'll echo what the United States Space Command indicated, that it was really, really unwise, negligent, and so forth, that what Russia did. Russia's not the only one that's done that. The United States has developed technology. India did a collision like that some time ago. You can find a simulation of the debris field online. But anyway, you can't shoot them down. That's not a good idea. Eventually, those satellites in low Earth orbit will they'll burn up in the Earth's atmosphere. There are other environmental concerns with that. But in any case, what SpaceX did, however, is it developed first DarkSat, which it darkened the coat of one side of the satellite to see if that would have an effect, and it did. It diminished the brightness, but it also increased the heat, not surprisingly, of the satellite, absorbing the sun's rays. So then they went to VisorSat, and VisorSat's a much more effective technique for both the operator and to mitigate the brightness. And so SpaceX indicated afterwards, after they developed and tested that technology, that all satellites that it launched after that point would have the VisorSat technology. You can also look at a number of other sites that include information about satellites and satellite operators and constellations. This is a database of nanosatellites that have been launched and or authorized. And as we see a closer image of this, you know, the size of these satellites can be very small, a quarter unit, 6U. These are kind of a CubeSat configuration. So the U is a single CubeSat dimension, and then you can build onto that. So 6U are those 6 of those CubeSat dimensions. A quarter is a quarter of it, obviously. And if you look over here, going back to one of these other databases, the numbers of the constellations, many of them are not huge, 36, 30, 25. All of these are in the double digits. But of course, then when we talk about SpaceX, we get into the thousands. So what I would like to say is a satellite constellation can be made up of any size of satellite. The constellation itself, the number of satellites, can be any size, and they can be from anywhere in the world. And particularly here, I'm showing US, but satellites can come from any country. Here we have some that you can see: Denmark, Canada, Japan, US, Japan, Brazil. So anywhere in the United States, anywhere in the world, we can have satellites. So what are we concerned about? Are we concerned about just the mega satellite constellations? And what is a mega satellite constellation? I would argue that we are concerned primarily, yes, about mega satellite constellations or mega constellations, but our concerns have to be focused on all satellites, because it could get to the point that the number of small sats, the number of smaller constellations in aggregate, could end up exceeding the number of satellites in a mega constellation. And if they all have brightness issues, then we're in the same place. So our concerns should lie with all satellites, but primarily we are concerned with the mega satellite constellations, because how many have been launched or will be launched. With respect to SpaceX Starlink, we're close to 2,000 now that have been launched since May of 2019. To put that in perspective, at about that time, there were 5,500 satellites, less than 3,000 of those satellites. This is 5,500 satellites in total orbiting the Earth. Less than 3,000 of those were actually operational. The other 2,500, we would argue, space debris or orbital debris. As an aside, whether you hear the term orbital debris or space debris, it's the same thing. It might be a bit nuanced what people consider to be orbital or space debris, but I use the UN definition and the definition of the Interagency Council on Debris or the Interagency Debris Coalition. And that's really any artificial object put into space that's non-functional. So a satellite that is working and functioning is not space debris. You might argue differently, but we're not considering that as space debris. But once it becomes non-operational, it does become space debris. So of those 5,500 satellites in 2019 or thereabouts, meaning thereabouts in terms of the number 5,500, about 3,000, just slightly less than 3,000 were operational, and the remainder were non-operational. So in that 2-year period of time, we have the United States, and one company within the United States has launched more than a third of what the total number of satellites happened to be in 2019. That's why we're concerned primarily with mega satellite constellations. And when you consider the fact that a lot of the companies that are seeking mega constellations, seeking to launch mega constellations, they're applying for a license for tens of thousands of satellites. For example, SpaceX applied for a total license capacity right now, I think 40,000+. There was just Rwanda just filed for, I think 300,000, if I'm not mistaken. Part of me wants to say 150,000, but it was above 100,000. So you can see the numbers can quickly get out of control. Now, whether they're going to launch 300,000 anytime soon, if ever, is another question altogether. But nonetheless, with all these applications going through and the license applications getting approved, then there's the capacity to launch those, and that's where the problem arises. Again, remember, we're probably, even with SpaceX, the 2,000 that have been launched, we're still probably below 8,000, between 7,000 and 8,000 satellites right now. So again, even mega satellite constellations, they can be any size of satellite. You could have 10,000 microsatellites, but if they were reflective, we'd have a concern. Or if they were all right near one another, such that their aggregate area became a brightness factor, that would be a concern. So any size of satellite. As far as the size of constellation, when do they become a mega satellite constellation? That's left to debate. In fact, recently in the Dark and Quiet Skies conference, one of the questions came up is, where do we define that number? How do we define that number? Some suggested 100 perhaps, but that's perhaps too low. Some suggested 10,000 or 1,000, that's too high. I don't know what the number is, but I would say probably 100 with an asterisk that it depends on the facts and circumstances is probably a safe estimate at the moment. But again, they can also come from anywhere in the world, given the Rwanda example and other countries that are vying to make sure that they have a place in the orbital environment. So we had SATCON 1, and then the Dark and Quiet Skies conference came about in 2020 as well, Dark and Quiet Skies 1. So we had SATCON 1, and then Dark and Quiet Skies 1. That was in September of last year, October last year. And their recommendations were quite broad. Fewer satellites, darken the satellites in all phases of the orbit, darken them to a minimum fainter than 7th visual magnitude at 550 kilometers. And that's where that range around 550 kilometers, happens to be where most of the Starlink satellites happen to be. LEO satellites on orbits as low as possible. And the reason for that is that the amount of time that they would be bright in the night sky would be less. Public repository of up-to-date and highly accurate orbital location data, satellite locations, making that as a public service so they're accessible, develop advanced algorithms for avoidance of bright satellites, develop a predictive model for satellite brightness versus orbit, support for simulations, more telescopes and telescope networks, development of a digital twin of the space environment and satellites, that's for more modeling and so forth, mitigations for radio astronomy, mechanisms and alerts for temporary dimming of satellites, mechanisms to know which spectra to throw out, clump satellites in parking and orbit rays, development of smarter instruments, make satellite locations more predictable, and much more. Both the full SATCON 1 report and the full Dark and Quiet Skies report are tomes. They're about 200 pages, but they're definitely exceptional, well worth reading material. So we also had additional, more detailed recommendations through Dark and Quiet Skies. And I wanted to show here, I'm not going to get into all of them here. And in fact, I'm not going to dive into many more than what I'm going to talk about on this page and the one just before. But what I wanted to emphasize is that a lot of the recommendations that came out of Dark and Quiet Skies 1 followed the SATCON 1 recommendation. So for example, recommendation 1 here, support the development of a software application available to the general astronomy community to identify, model, subtract, and mask satellite trails in images on the basis of user-supplied parameters. This is referencing SATCON 1, recommendation 1. So recommendation 2, R2 here for Dark and Quiet Skies, support simulations of the effects on data analysis systematics and data reduction signal to noise impacts of mass trails on scientific programs affected by satellite constellations. Aggregation of the results should identify any lower thresholds for the brightness or rate of occurrence of satellite trails that would significantly reduce their negative impact on the observations. And as you see to the right of these, it's talking about who these should be directed to. Recommendation 1, R1, to observatory leadership and science funding agencies, and then R2, the same as above, but also industry with respect to provision of data. So you can also see below that the SATCON 1 recommendation 2 fed into recommendation 3, Dark and Quiet Skies, and in conjunction with mitigation reports, the mitigations report M8, one of which I just read, and SATCON 1 recommendation 4, we had the development of a predictive model. So the SATCON 1 report really fed into the Dark and Quiet Skies report, and we've been building on that since then. And here, if you couldn't see that before, I'm just focusing on the fact that the SATCON did come into play. So Dark and Quiet Skies involved observatories, industry, astronomy community, and science funding agencies. If you're wanting to know what the difference is between the SATCON workshops or conferences and the Dark and Quiet Skies, SATCON was pretty much focused on the United States. It was through NSF, NORLab, and the AAS, whereas Dark and Quiet Skies was through NORLab as well, participated, but through the United Nations. So the United Nations Office for Outer Space Affairs, or UNUSA. So I want to take a moment, I've been using that word a lot, so I want to take a moment and present an interlocutory question, because one of the issues that came out of SATCON 1 and is followed through is explaining why, or what do we need to do? Why are we even focused on the dark skies? Is it just astronomers that are concerned? Is it just the astronomy community? And I would argue that it definitely is something more. And I think that the conclusions of SATCON 1 and Dark and Quiet Skies and continuing on would consider that. But that is, I view it, the orbital space around Earth, what we're talking about is the Earth's environment. And so we need to regulate it as such. So here are some other images of just what satellite streaks can do. I mean, we saw in the background here, you can see the original DCAM image that I showed you, but we have other images here that show the paths of satellites. The one in the background to the left, the photograph with the different segmented, the CCD fields, that's the DCAM image. The image to the right and the middle happen to be images from the use of a Baker-Nunn camera up at the University of Calgary, and I appreciate the sharing of those images with me, because one of the things that I have been wanting to do and have been doing that I don't have time to really talk about further tonight that much is to take the images and go in using the TLE data. Remember, I talked about TLE, two-line element data that you can obtain from Celestrak or Space Track, and using that to identify the satellites in the images, so that as I do it reverse, I can try to work toward a predictive software as well to help out. But more or less, I've been looking at these images in part for the policy side, but in part using Python to go through the TLE and identify the specific satellites that cross the field of view of these different telescopes. These images are much more, like the image to the right is a much longer exposure than the DCAM. I think the image on the right is a number of hours. And if I remember correctly, I don't remember the exact time on the one in the middle at the moment, but the one on the right was several hours, and it was broken up into different segments of hours. So what is the Earth's environment? Now, I will acknowledge that I borrowed some of this from a presentation that I made in the Dark and Quiet Skies this year, but I think it's really important because it drives home the whole regulatory philosophy of why we should be focused on what's going on in the Earth's orbital space. So the Earth's environment is the terms most often applied to the Earth or some parts of the Earth. This environment encompasses the interaction of all living species, climate, weather, and natural resources that affect human survival and economic activity. But what I would do is I would suggest that the environment encompasses the interaction of all living species, climate, weather, and natural resources that necessarily includes the effects of each of them and their respective activities on each other. This necessarily means that the environment includes the effects of humans and their activities on fellow humans, their activities, natural, economic, or otherwise, other species activities, and natural resources. Now, not only do we have to, so when we're talking about the Earth's environment, the question arises, where does Earth's environment end? Do we call it the troposphere or the stratosphere, the mesosphere, the thermosphere? You will see, I read an interesting article that we're getting to the point where climate change is actually expanding the troposphere, so that we're actually going to get to a point where they were saying that at high altitude, planes are going to have to fly even higher than they are right now to avoid turbulence because the troposphere is expanding. So I guess, who would have thought, but this is perhaps fluid if things are not taken care of with the climate. But one of the ways to define Earth's environment would be to cut it off at the troposphere or the stratosphere, mesosphere, or thermosphere. That's a possibility. Another possibility would be to look at the orbital areas around Earth. So we could look at the inner Van Allen belt. So we could look at this area here, which might just be the low Earth orbit around here, because remember, low Earth orbit, that where the SpaceX happens to be, is about 550 kilometers. I would say that low Earth orbit is probably from about 200 to 2,000 kilometers. That's the broad range of low Earth orbit, or LEO. So we could do that. We could talk about the actual geostationary orbit, which is out in the range of 40 kilometers. We could go further to the graveyard orbit. So graveyard orbit is geo plus 300 kilometers. Or we could even talk about Lagrange points. And we could talk about, where we're sending satellites that are out in the L2 area, or any of the other Lagrange points. Or we could expand even farther and think about wherever we send a man-made object. Planetary protection kind of drives home this possibility when you consider what is planetary protection. So planetary protection is the practice of protecting solar system bodies from contamination by Earth life, and protecting Earth from possible life forms that may be returned from other solar system bodies. So look at that first part though. Planetary protection is the practice of protecting solar system bodies from contamination by Earth life. So already our philosophy, our policy in the United States on planetary protection is protecting other solar system bodies from contamination by what might be here on Earth. And so when we think about that, we think about extending that to, or the next is to extend that to all celestial bodies. And think about the Voyager spacecraft and wherever they may go. So I would argue that to a certain extent, the Earth's environment extends to wherever we expand the Earth to be. And our Earth present is currently in interstellar space with the Voyager spacecraft. Now, for purposes of regulating constellations, mega constellations, in terms of light pollution, solar reflectivity, space debris, we don't necessarily need to think that far out. But nonetheless, I would contend that that should be on our mind. We already think about it in terms of planetary protection. And so we should be cautious about what we do with Earth's orbital space or any other part of space that we happen to visit. And just for your information, you all probably, this community's probably seen the famous image of the pale blue dot where the Voyager spacecraft looked back at Earth. This is actually the reverse angle, or the reverse, with Earth looking to the Voyager spacecraft in the distance. So of these choices, we have quite a variety to choose in where we define the Earth's environment. We should have some definition, but I think that the global argument applies to any of them. And that is, we need to be careful about what we do when we send things to other places. And we can see that in no uncertain terms when we look at I'll get to that in a moment, I guess. I'm getting a little bit ahead of myself. So for purposes now, though, I would argue that for purposes now, we can limit it to the range, within the geostationary orbit range where we send satellites. We should be concerned about all of that, orbital debris, the reflectivity of the satellites, and so forth. So defining Earth's environment, again, This necessarily means that the environment includes the effect of humans and their activities on fellow humans, their activities, natural, economic, or otherwise, other species activities, and natural resources. The reason for this is, of course, humans use celestial bodies for navigation. Non-human species use stars as a source for directional information. We use celestial bodies in the dark sky for religious and other cultural purposes. And we use the dark skies for astronomy and scientific research. Going back to the Decan image and the Baker-Nunn images, we don't want to destroy the ability to use the dark sky for the environment. I mentioned earlier that I've been using software to track where the particular satellites happen to be and their images. And so this is a rough calculation using software of the different satellites that were crossing this particular field of view. There are going to be more satellites here than may appear on the there are more satellites on the right that may appear on the left, because this I ran through all satellites, and not all the satellites will necessarily be reflective. So the image on the left obviously only has the streaks for those that were reflective. But you can see similarities. I mean, you can see, like here, this mark here is down in the left corner. You can see this faint satellite over here and crossing. So it does match up. But now this is the limited time period. But if we looked further over a few hours, so this is now a trajectory. So from the May 18th, 2021 to May 19th. So May 18th at 11:11 to 1:18 on the 19th. So that's really about what, a 2-hour period. So 2 hours and 7 minutes. These are all the satellite streaks that you have going through this area. This is not the field of view. This is much wider than the field of view. The field of view on the left is, it's so basically 4.5 degrees here on the right ascension and about 4.5 on the declination. And you see here, this is 25 and 40. But I wanted to show the scale of the satellites that traverse that area just in a 2-hour period. So clearly, astronomy and scientific research involve significant economic activities. A lot of people contend that, well, it's a matter between the satellite companies and astronomy is not economic activity. That's not accurate. Proposed NASA budget, this is just the US, $24.8 billion with $7.9 billion to the science division. The James Webb Space Telescope, everybody's going to watch that, I think this December, $9.7 billion. The Extremely Large Telescope, $1.3 billion. Operations of observatories, just to give you an idea, the European Southern Observatory, $150 million. The National Radio Astronomy Observatory, $88 million. The Rubin Observatory, $40 million. The WM Keck, $17 million, just to name a few. There's a lot of money being spent on astronomy. In each of these circumstances, the diminution of the dark and quiet skies adversely affects diverse species and their activities. Beyond what I've just described, then we also have the issue that I mentioned at the very beginning, that the reentry of satellites creates aluminum oxide or alumni, and that could affect our Earth's atmosphere. And just a last point on this particular item, satellites reduce the overall darkness of the night sky, elevating the brightness of the night sky by at least 10%. And the concerns are that with the number of satellites anticipated, that will increase significantly. And that's just the overall darkness of the night sky. That's not Chicago versus Naperville or, one of the dark sky areas that the NAA has. That's the overall darkness of the night sky. And even with the debris, I mean, why regulate? Well, look at the image on the right and look at the islands of plastic on the, or the island of plastic on the left. And, you know, we don't want, humans have a tendency to treat what they don't see as a garbage disposal. And we've got to change that perspective. Earth's orbital space does constitute a natural resources, and it's precious, it's finite, and it should be treated as such. With that, then we come back, as we talked about SATCON 1, we talked about SATCON, or Dark and Quiet Sky 1, and now, then this year we had SATCON 2. And SATCON 2 built upon what came before in SATCON 1, Dark and Quiet Skies 1, some of the environmental aspects that I've been talking about. During that time period, people went in and completed additional studies. But I just wanted to mention again how I share Jim's perspective, that I think it's really significant that the Naperville Astronomical Association had 3 members participate in SATCON 2, which is significant because it wasn't, I mean, I'm not just talking attending. We were on the working groups, and so we were involved in the meetings and so forth. And it was a finite number of people. So I just find that to be impressive, and I think you, as a NAA member or viewer, should consider that. Just with respect to Rick and Jim, they were on the community engagement working group, and I was on the policy working group. So recommendations coming from the observations working group, I'm going to run through all of the working groups here and their recommendations from SATCON 2, is to establish a SAT hub where you can just get tons of information. And here's a diagram that they came up with. So on the left, we've got astronomical data repositories such as Trailblazer, radio data, spectroscopy, visual records, and astrophotography, an orbital solution portal with ephemeris, with errors, general perturbations with errors, 2-line elements, documented operator best practices, software tools, TrailMask, which I'll mention in a moment, and Past Predict, but you can kind of intuitively gather what TrailMask happens to be and what Past Predict might be. The ephemeris parser, simulation tools, Arcade, or OrbitPy. These are orbital determination through the PI's Python. Accessible documentation for all software, contributor guide, training curriculum, real-time collaboration. So having that SAT hub with all that information available, building a training curriculum, making sure that best practices for operator include public sharing of data. The algorithms working group came up with recommendations for creating a test data set, create TrailMask, which, as you intuitively have probably figured out, is to mask the satellite trails, create Past Predict to predict the passing of satellites, and create simulation tools so that you can help simulate and identify what the issues happen to be and the impacts and so forth. So far we've got the observations working group and the algorithms working group. The community engagement working group focused on 5 areas: astrophotography and astrotourism, amateur astronomy, or rather, these are the segments, the population segments from which they obtained input. So astrophotography, astrotourism, amateur astronomy, indigenous communities and perspectives, planetariums, as well as environmental and ecological concerns. They came up with recommendations that include the duty of satellite operators to consult with all stakeholders, all of the people that are involved or affected by the satellite operations in the Earth's orbital space, or now we're all going to say Earth's orbital environment. The need for more information and communication, the need for those stakeholders to participate and engage with industry. You have to talk with them. We have to engage them. And we really had the fortune that some forward-thinking thought leaders in the industry participated in SATCON and Dark and Quiet Skies both, to help to come up with particular perspectives. And I'll note that nothing necessarily was an official company position, but nonetheless, many of the major companies, Amazon with Amazon Kuiper, SpaceX, Starlink, contributed individuals to work with these groups to identify concerns and hear the concerns and develop possible tools for mitigation. So we all need to engage with industry, and that's down to the local level, the local astronomical societies such as ours here, and that comes down to even you as an individual member or viewer to participate. Recognize the rebalance of power structures, learn from the past, and what this means is, I saw it in internet law as well. The technology develops, law has a hard time keeping up, and bad practices develop unless you put a stop to them. And we can see that in some recent social media companies that have been called to task for different behaviors. So that's something to think about. Learn from the past and not let the technology develop and get ahead of the law and the policy before it's too late. Science versus internet, a false choice. This basically refers to, and Jim can correct me later if I'm wrong, but what we're talking about here is sometimes people make a dichotomy that we've got to have internet access, right? The satellite constellations, a lot of the satellite constellations are out there to provide internet access. Let's say that, or that's one of their designs. So for example, Starlink will provide broadband service, internet service. And that's been one of their goals that they've been talking about, to get internet service for areas that can't otherwise have very high speed internet, if internet at all. Very noble and altruistic endeavor, not that they won't be charging money for it, but there's not a false choice that you have to save science, you've got to eliminate internet in these areas or eliminate internet connectivity. Not at all. And I think that anything that's come out of the most significant aspect that's come out of these meetings, SATCONs and the Dark and Quiet Skies, is that industry and science can work together. All of the stakeholders can work together, and we can find a balance. If people will listen, solutions can be reached. So there is no false choice between science and the internet. And then we definitely need better international regulation and global oversight. And that's where the policy working group came in. We addressed international law and treaties, U.S. national law. We focused again on orbit as environment, and we included the industry perspective. The industry subgroup was part of the policy working group. The orbit as environment is really, I will mention, and the reason that I put that segment in here in tonight's presentation, I'm running near the end of my talk here and I'll open it up for questions. But the reason for that is that it's a really hot button issue. It's not necessarily the only reason that we need to regulate Earth's orbital space, but it is a strong reason. We have to treat it like the environment. We have all these space debris, orbital debris issues that we need to address, and we're already starting to regulate those. So it's not a far stretch to regulate it so that we can protect science and the dark skies as we know them. So SATCON 2 occurred this summer. The report was just released late October, another tome to put on your reading material. And then we've just concluded the Dark and Quiet Skies for Science and Society 2. implementing the recommendations, and that report is being currently drafted. I'm going to skip over these. That goes into just a little bit more detail on some of the changes that could occur. I do want to mention specific changes, like in U.S. regulations, some amendments that could occur. But I want to talk about Viasat versus the Federal Communications very quickly. If you haven't heard, the FCC approved Starlink. Starlink already had a license that it filed for modification. Viasat had not really raised a number of arguments than the original application, but then when Starlink SpaceX came in to modify the license, Viasat jumped on the opportunity and opposed it, arguing a whole number of issues, including protecting the dark sky, the environmental issues, and so forth. And the FCC said that it did not have to require a full-on environmental impact assessment or an impact statement. And I agree with that legal conclusion for a number of reasons that I can get into in questions if we want. But nonetheless, when the FCC denied the Viasats they didn't disregard, they ruled against Viasat in opposing the application. Viasat filed suit against the Federal Communications Commission, and that was actually filed in the United States Court of Appeals for the DC Circuit. July 20th, Viasat was trying to get an emergency order to stop all launches. That was denied, and the briefing has been concluded so that we should actually, oral arguments are December 3rd. So we'll see if those are live. I don't know if they'll be live, but just so that you understand very briefly why I say the legal conclusion was correct. Right now, when SpaceX or anybody completes Form 312, they are asked the question, would a commissioner grant of any proposal in this application or amendment have a significant environmental impact as defined by 47 Code of Federal Regulation 1.1307? If yes, yada, yada. If no, then you don't need to worry about it. So if you look at 47 CFR 1.1307, the FCC's interpretation of NEPA, the National Environmental Policy Act, is very narrow, so that the 1.1307 lists really only terrestrial concerns. And so when you're filing this application and your satellites are going to be off Earth in orbit away from the terrestrial space, then the answer is no. Now the question is the FCC wrong in limiting the scope of environment to terrestrial-based concerns? I would argue that you could interpret NEPA, which is the overarching statute, and then the regulations are the Council on Environmental Quality, CEQ, implementing regulations. We don't have time to get into all of that, but you could argue that those regulations encompass Earth's orbital space or Earth's orbital environment, but they don't explicitly do so. So I don't think that the FCC is strictly wrong in interpreting NEPA, but I also think that the FCC should reinterpret NEPA so that it becomes broader. And barring that, I think that the regulations should be amended. So that's my report on SATCONS, satellite constellations. I know that we've used SATCON here two different ways. SATCON, the SATCON 1 and 2 were the conferences or the workshops, but SATCON, satellite constellations, and mitigating their adverse effects. So with that, I'd like to turn it back over to Jim, and I'm happy to take any questions.
Yeah, hi, Charles. We do have a few questions. I'll start with my own first here. Is with the new formed Space Force, do they have an opinion on this as a significant issue or not an issue at all for someone like Space Force?
You know, that's a really good question, and I'm going to nuance my answer as any good lawyer would do. I would say that I don't know of an official policy perspective on the impact of satellites on, let's say, astronomy or the dark sky. However, just recently, for example, Space Command and I think even Space Force came out with the issue or statement with respect to the Russian anti-satellite maneuver. And so in that respect, I think that there is a concern about the orbital space and about orbital debris. But I don't believe that the Space Force has come out with a specific policy position on the visual effects of satellites in the night sky. But it's interesting that you asked that question, because I will tell you where we do see some hints of that occurring. And I think it only has been occurring because people have been talking about it. And we've had SATCON 1 and 2. So, for example, the FAA, the FCC, and NOAA implemented or amended their regulations relating to satellites. And the FAA just looked at, not too long ago, they looked at SpaceX's application for launch activities at a particular location in Texas near South Padre Island, which I remember from spring break days, but completely different story. And interestingly, then the FAA addressed that, and the FAA identified that in some aspects that a visual effect that should be encompassed within a environmental impact statement or environmental assessment, one of the visual effects could be the effect on the night sky. Said merely in passing, not much more than that. It didn't really focus on that beyond the mention in the report at all. But I think it is significant that the FAA identified that in its report. Another location, talking about mega constellations more generally, is that the Government Accountability Office, the GAO, looked at recently FAA's regulations and pointed out that the FAA really needs to be doing more about addressing mega constellations and the effects generally that mega constellations may have on Earth's orbital space. It did not mention, necessarily visual effects or the dark sky, but nonetheless, it did identify the fact that the FCC has just come out with its new regulations regarding orbital debris and indicated that the FAA really needs to circle back and address some of these regulations. So here's an opportunity then for all of us, because you can comment on proposed regulations. The NAA can, if it decided to do so at the appropriate level. Individual citizens can do that, and we should. People that have an interest should comment on those proposed regulations and keep driving home the point that we really need to have the night sky, the dark sky, the visual effects of the satellites on that considered when granting these licenses. So I know that didn't answer your question directly head on, but I hope it suffices for the moment.
Okay, Charlie, thanks. That did very closely, but kind of to follow up on what you were just saying, I'm going to go a little out of order the questions asked here. Again, another one of my own. Is there, on that point that you were just making, is there a congressional leader or, whether it's in the House or Senate that kind of champions this issue?
Well, that's another very good question. And as it happens, and people watching this are going to think that you and I planned these questions, but I did not know these questions in advance. But actually, Tammy Duckworth of Illinois, Senator Duckworth of Illinois, is one of the senators that has taken a lead on this. I can't remember the other senator that that wrote a letter with her specifically, but they do have taken a leadership position and have asked that the FCC examine these particular issues with respect to the effect of satellites on the dark sky.
Great.
So I would, along that point then, following what I had said before, I would encourage everybody that's listening, that's watching, to particularly here in Illinois, and particularly the Naperville Astronomical Association, to send an email, to send a thank you to Senator Duckworth for paying attention to these issues. And I've actually had communications with some of her staff members about the issues in the past as well. So they are on top of it.
Okay, great. The next question is, do all these satellites cause any problems with radio astronomy? I think you meant detecting false signals.
Yes, and I'm answering yes, and kind of a not, just kind of the way of saying that's an interesting question, or that's a good question. So the satellites have the potential to affect radio astronomy, and they have the potential to, I would not so much say, and I'm not an expert on radio astronomy by any stretch of the imagination. I wouldn't even say that I'm a novice on radio astronomy, but the information that I have picked up from what I've read and understood separately and through the SATCON and DNQS endeavors is that it's more the concern that the frequencies will mask, they'll not be identified as false positives necessarily, but they'll mask information that we could otherwise obtain, so that the satellite signal in particular frequencies would prevent anything else from getting through or being able to be identified. But that is a really good question, and what I'd suggest is following up on that with more information from one of my radio astronomer individuals. But one of the interesting things, though, also about radio astronomy is that, radio astronomy, there are regulations already that protect, not so much, it's like the equivalent of a dark sky area, right? It's the area around a radio observatory, and it's protecting that area from interference from terrestrial based activity, so that it doesn't interfere with the ability of the radio astronomers to do their work. And so it's a perfect model for adopting regulations that similarly would protect dark sky areas, or focus on the effect that these satellites are having on the dark sky more generally. As a corollary to the regulations in the United States that are protecting the radio observatory sites, and I want to make a clarification, there are no regulations, radio astronomy regulations, that are addressing the issues that we're primarily talking about today, and that's the effect of the satellites on that so much, except that satellites are precluded from going into particular frequencies, frequency areas, the allocation of radio frequencies. But the corollary that I was going to mention is that in addition to the United States having regulations protecting the radio free zones or radio quiet zones, so to speak, the ITU, the International Telecommunications Union, has substantial regulations and guidelines on radio astronomy. But I don't believe, and I'm going to put my hat on this as the answer to your question, I don't believe that it's so much that we would identify the frequency of a satellite as a false positive as it would that the satellites broadcasting at certain frequencies passing through the field of view, as you know, using that analogy for the radio observatory, would mask our ability to see radio signals behind it, if that makes sense.
Okay, great. We have an email question here from Rick Gehring. You mentioned the desire to keep LEO satellites at the lowest possible altitude, which is good for big astronomy since it minimizes intrusions during the period between astronomical twilights, but bad for outreach since it maximizes intrusions during twilight when outreach is necessarily conducted. Do you think there's a way to avoid this trade-off, or is it inevitable?
That's a really good question and an insightful thought. My hope would be that there's a way to, just as we said that there's not a false trade, but that it's a false dichotomy to say that we have to choose between internet access and science. Hopefully there would be a way to allow us to avoid completely diminishing outreach opportunities. One of the things might be in the amount of time that observations occur, right? And what I gather by the email is we're talking about outreach where we're able to go out with people to sites, dark sky sites, and show people the stars and so forth. And we do that more than being out there, let's say at 3 a.m. And so it might also be, though, that the ability to observe the dark sky in that context is more of a in the moment aspect, whereas opposed to some of the observatories where we're talking about the deep night observations are longer exposures of hours or minutes. Like that DCAM image was 333 seconds on the exact same, even though it was rotating, obviously, that exact same field. So that might be one aspect, but yeah, I would hope that we would be able to find a balance and find some way to make sure that all active participants, all stakeholders are protected. And I think that was, with Rick and Jim on the community working group, that's really where their focus happened to be in talking about that and ensuring that all stakeholders have a voice. It's not just the scientific astronomers and the satellite operators at the table. It's indigenous people, it's amateur astronomers, it's people that just want to go out and look at the night sky and enjoy it. I mean, what we hope, obviously, is that we don't lose all dark sky areas. I mean, already I don't see in the suburbs, certainly the people in the city do not see what we see in the suburbs. And there's an Adler program with youth working through, on astronomy and so forth, and taking them, doing activities, but one of them is taking them out to where they can actually see the night sky. And it's amazing to hear the impact that has on them. But then, as you all know, this community knows that there are dark sky areas that are much darker than just the suburban night sky. And it's the hope that we don't lose those, because even in the suburban night sky, while I can see more than I can see in Chicago, I still don't see the Milky Way galaxy. And so, hopefully we will have locations nearby and we don't have to go to the ends of the earth to be able to see that.
Okay. Rick has another question for you too. Do you know why none of the environmental orgs like Sierra Club, etc., filed amicus briefs in Viasat?
No, I don't know. If I were to guess, two possible reasons: limited resources, but also limited knowledge, and just it's not at the forefront of their radar. And I might be completely mistaken, and that's a really good question, and that provokes the action of reaching out to them. We should reach out to them and see what their perspective happens to be, and if they are able to do anything. On the other hand, just from my perspective, one of the reasons why they may not have filed an amicus brief in the Viasat case is I really believe that Viasat is wrong on their legal argument. I don't believe that the FCC did anything wrong. SpaceX did not do anything wrong in answering the question the way it did on Form 312. And the FCC did not necessarily do anything wrong in interpreting NEPA and the CEQ regulations, because right now they do not explicitly include anything about the night sky or celestial or being able to see the stars or so forth. And so I think that the FCC was not wrong. Maybe they were short-sighted, but I don't know that it was illegal the way that their interpretation happens to be. So that could be a third alternative, in that, a lot of times in cases and arguments, a lot of organizations will be very choosy in their test case, because you don't want an adverse ruling on a case that's not really solid for you. And what I mean by that is that if you push an argument on a case that's not rock solid on your position, that's not the best that you can imagine it can be, the danger is that you get a ruling against you on a weaker case, but that ruling extends beyond the contours of that case. And so then you're going to have to fight that adverse ruling down the line. And that's a lot of times why organizations that are doing amici briefs and so forth, they will only participate in those that they believe that there's a strong argument for. But in answer to the question, I really don't know why any one of them was not involved. It could have been any of the reasons I mentioned or any other reason, but it's a very good question, and one that we should at least invite and see if they are interested in participating, and where I would recommend that their direction be focused more so than Viasat, because again, remember too, Viasat is a competitor of SpaceX, and there are ulterior motives going on with Viasat wanting to halt SpaceX launches. As Viasat doesn't want that bandwidth, that area, that population of that particular orbit so saturated that it's going to have a limited number of opportunities or not be able to get there at all. And that's a point really quickly. Well, before I finish, so where I would suggest that everybody direct their efforts at this point is to filing comments and responses to the regulations that are filed and the license applications. You can say, you don't have to say that the FCC was wrong in the past. Advocate that the FCC address these issues, that the FCC pick these issues up. So in any case, I forgot the last thought that I was going to make, but probably just as well. So good question.
Okay, so that's kind of, again, we really didn't coordinate on this, but and one of my own questions again is, are these organizations like SATCON and such reaching out to media outlets, big name ones like TED Talk or something like that, to present this information, maybe to bring it to the awareness of the Sierra Club? Maybe they're not even aware of it.
I do know that there's definitely an outreach by the organizations behind SATCON and Dark and Quiet Skies. They did have press releases. I'm not aware of the specific channels or communications at that level, but I will inquire and I'll pass that along to some of the people and to see and get back, and maybe I can send back that answer once I get it. Somehow we can filter it through. But I think it's a good question, and given that the Dark and Quiet Skies 2 report hasn't come out yet, there's still the opportunity for that to occur. And given that the SATCON 2 report only just came out, maybe that is something to pick up on as well, because I do think we need a collective brain trust, and we need all the help that we can get and advocating for these. And a lot of those environmental organizations have connections and avenues that the astronomy community might not. One thing to mention on the Dark and Quiet Skies 2, some of the next steps will be eventually that the report will be going to UN meetings in the first part of the year. And that's the objective, is to have these reports done for that purpose, and then push forward and to kind of continue pushing this as a topic on the UN. COPUOS, the Committee on Peaceful Uses of Outer Space. But to your point, one of the things that I did not too long ago was another part of the United Nations Environmental Program was having its UNEA conference. I think it was UNEA 5 coming up, and they were taking solicitations on topics that should be addressed or included. And I submitted a letter to UNEA advocating that these issues be addressed. They didn't do so, they didn't pick it up, but they at least responded to me and acknowledged it. So I think that those efforts, we just keep driving home the point. I think that's why these issues start to come out in the GAO report or be mentioned by the FAA. And there was something else that was an indication that we were starting to get some traction, and I just can't remember it. But by talking about it and all this communication, exploring all these channels, people are picking up on it, and that's what we need to continue to do.
Okay, at this point, Charles, I don't see any other questions unless maybe Jim sees one, but I think that's all the questions we see. We really appreciate this conversation, and I think that's it.
All right. Well, thank you for the opportunity. I appreciate it. I hope it's informative. And I think, again, I want to thank Jim and Rick for participating on SATCON 2 with me. And I think that, we've got a strong organization here, and at the forefront of that, and spread the word, because that is really how these issues come to the fore. Pass the word on to Senator Duckworth, because the more, just one final point, I don't know what the calculus is anymore, but when I worked for a senator, United States senator, in the state office, we would get, this is pre-internet, or I mean, the internet was there, but it was pre-internet as we know it today. Certainly pre-Web 3.0 or Web 2.0. We would view and weigh the manner in which people communicated with their senators or representatives. So a phone call was worth, let's say, I don't remember the exact number, let's say it's worth 1 point. A letter would be worth 5 points. And so there was a weighting of those. And you can imagine that weighting reflects the amount of time that is spent. So if you pick up a quick phone call, it's better than nothing. If you send an email, it's better than nothing. A longer email is better than a short email. but they listen. They do go through those, and they count the number of people that they hear. And the points were not so much as points as it had a correlation to the number of constituents that represented. So if somebody took the time to write a letter, there was an algorithm that basically said that individual, for every one person that took the time to write a letter out like that, there are 5 or however many more citizens, constituents that are thinking the same thing that just didn't write the letter. So every time that you do something, you are voicing your opinion, but you're actually weighing in for more than just yourself. So it's really important to do that. And we're here in Illinois, not only do we have interested parties within our organization, the NAA, participating, but we have Senator Duckworth, one of 2 senators that's really taking a leadership position in this context. Let's let her know so that she continues there, because if she doesn't hear from anyone, unless it's a passion project for herself, that might fall by the wayside. I doubt it. I think that it is a passion, but nonetheless, the more that we let her know and our other representatives know, the better. So again, thanks so much, everybody, for listening and inviting me to once again speak in front of the NAA.
Thanks, Charles. Have a good evening, everybody.